Jai Shri Gurudev. Dear students, welcome to session 7 of module 3. So in today's session we will discuss about PD, PID controllers and the working principle of all these controller operations will be discussed. So a brief introduction to PI, PD and PID controllers will be given in this session. So in the last session we have discussed about steady state errors and error constants and we have solved few problems on that. So let's start with PI, PD, PID controllers in today's session. Now the usefulness of PID is to control the general applicability to most control systems. Okay, so in particular when the mathematical model of the plant is known to us and therefore analytical design methods cannot be used, PID controls prove to be the most useful. So in this field of process control system, it is well known that the basic and modified PID control schemes have proved their usefulness in providing satisfactory control. So although in many situations they may not provide optimal control, but a control is provided to a suitable level. So and one more interesting thing with respect to PID control is uh, that more than half of the industrial controllers which are used today are PID controllers or modified PID controllers, because most PID controllers are adjusted one side and many different types of tuning rules have been proposed in the literature currently. So using these tuning rules, delicate and fine tuning of PID controllers can be made on site. So basically coming to the modes of operations of the controllers, so each mode control has specific advantages and limits in the PID controllers. One is on off, which is also called as bang bang control, proportional control, proportional plus integral control, proportional plus derivative control and proportional plus integral plus derivative control. So that is why it is represented as P, PI, PD and PID controllers based on the specific type of controlling operation provided by the controllers. So let's take up this one by one. Coming to on-off control, this is the simplest form of control what we have, which is shown in the figure here. So for a specific temperature and time, the power measurement of a waveform is shown here. Here the red color waveform indicates the set point and the green color waveform here indicates the error point, and the output of the system is shown here with a square waveform in blue color. So first coming to proportional control P. In proportional mode, there is a continuous linear relationship between the value of the control variable and the position of the final control element. So as you can see here, Kp is the constant value, proportional constant value for the controller. E of t is the error signal and B is the feedback signal what we have, and Cp of t is taken as Kp into E of t, right? So here this is controlling your plant proportionally, and the output of the proportional controller is given as here. You can see Cp is equal to Kp into E of t, that is the proportional controller constant into the error signal E of t. So this is the value that we have. Now the transfer function can be written as equal to Cp of t by E of s is equal to Kp for your proportional controller, with Kp as the proportional controller constant value. The gain is increased because of this. The system responds faster to the changes in set point but becomes progressively underdamped and eventually it becomes unstable. That is the main disadvantage of proportional controller. Though it is giving the response in a faster way, the response is not so stable. Now coming to proportional plus integral controller. In integral control, it describes a controller in which the output rate of change is dependent on the magnitude of the input. Specifically, a smaller amplitude input causes a slower rate of change of the output. And this is what is shown in the figure. We have given an input. Here we have an integrator, a constant integrator. which generates an output. So integral output will be a constant value like this. So the major advantage of integral controller is that they have a unique ability to return the controlled variable back to the exact set point following a disturbance. And the disadvantage of integral controller is that it responds relatively slowly to an error signal, and that it can initially allow a large deviation at the instant the error is produced. So because of this, the system becomes unstable and the operation becomes cyclic. For this reason, integral control mode is not normally used alone, but it is combined with another control mode. So this is the basic block diagram of a proportional plus integral control, wherein it is a combination of proportional and integral, which is represented as Pi. As you can observe here, so we have combined integral and proportional operation together here using an adder. So Ki and Kp are the proportional and integral constants what we have, which is generating the output as Cpi. And Cpi of t is taken as, so this is the equation what we have for the proportional plus integral control. Cpi of t is equal to Kp into E of t plus K into integral of E of t dt. So try to remember this expression for Pi controller. Now proportional plus integral controller equation, we know this is the equation that we have, and the transfer function is given as Cpi of s by E of s, which is equal to Kp plus Ki into 1 by s in the Laplace domain. So this is the equation what we have in the Laplace domain for Pi controller. Now coming to proportional plus derivative control, here we have a combination of Kp and Kd. Okay, so derivation is derivation plus proportional controlling action is taken together, right? So for this particular system, Kp dt is taken as Kp into E of t plus Kd into dE of t by dt. So this is the value what we have for proportional plus derivative control. So Kp into E of t plus Kd into dE of t by dt is the equation what we have, and the transfer function for proportional plus derivative control is given as Cpd of s by E of s is equal to Kp plus Kd into s. So this is the transfer function for a PD controller. Next, coming to the advantages and disadvantages of this proportional plus derivative control. The stability and overshoot problems that arises when a proportional controller is used at a high gain can be mitigated by adding a term proportional to the time derivative of the error signal. And also the value of the damping can be adjusted to achieve a critically damped response. So this is the type of the response what we are going to get for a PD controller. Now coming to the other part of PD controller, the higher the error signal rate of change, the sooner the final control element is positioned to the desired value. So we need a higher error signal. The added derivative action, it reduces the initial overshoot of the measured variable and therefore aids in stabilizing the process soon. And this control model is called proportional plus derivative control because the derivative section responds to the rate of change of the error signal. And this is the type of the expected output what we are going to get out of a derivative control. As an example, it is shown. So we have a linear input which is becoming a constant output here. So a proportional plus integral plus derivative control, that is PID control, is represented with a block diagram like this, wherein we have a combination of all these three controllers, that is derivative control, proportional control and integral control together. So the equation for your PID controller is given as Cpid of t equal to Kp into E of t plus Ki integral E of t dt plus Kd into dE of t by dt. So, and the transfer function for a PID controller is represented as CPID of S by E of S is equal to Kp plus Ki into 1 by S plus Kd into S. So coming to the operation and advantages of PID controller, though PD controller deals neatly with the overshoot and rising problems associated with the proportional control, it does not cure the problem with the steady state error. And also it is possible to eliminate this while using relatively low gain by adding an integral term to the control function, which becomes like this. So almost we are able to get a proper output using a PID controller. So the characteristics of PI and PD controllers are K for proportional controllers, rise time decreases, overshoot increases, there will be a small changes in the settling time system, and steady state error decreases. Where coming to integral control, rise time decreases, overshoot increases, settling time increases, and steady state error get eliminated. And KD controller, that is derivative controllers with CL response as KD, has small change in the rising time, overshoot decreases, settling time decreases, and there will be a small change in the steady state error. So this is the overall characteristic of a PI and D controllers. Now coming to the tips for designing a PID controller. So first thing is we need to obtain an open loop response, and we have to determine the needs that should be improved. And according to that, we are supposed to add proportional control to improve the rise time. Then we need to add the derivative controller to improve the overshoot, and we need to add an integral control to eliminate the steady state error. So and we have to adjust each of this Kp, Ki and Kd value until we obtain a desired overall response. So lastly, to keep in mind that you need to implement all the three controllers, that is proportional, derivative and integral, into a single system. If it is necessary, for example, PI controller gives a good enough response, then you don't need to implement derivative controller to the system. Then keep the controller as simple as possible. This is one thing that we can keep it in our mind when we start the designing of a PID controller. We have discussed about PI, PD and PID controllers, and we have seen the advantages and disadvantages of all these three controllers, and we have evaluated the output equation for the PID controller along with the transfer function value. So a basic introduction to PI, PD and PID controller is given in today's session. You have to, if the question is asked like you have to explain PI, PD and PID controllers, you have to write the block diagram along with the necessary equations and the transfer functions. So these are the books which you can refer for the prescribed contents. I hope today's session was informative and interesting. Thanks for your patience listening. Have a nice day.